Alright guys, my name is Jesus Lopez and today I'm going to be presenting the differences between assembly language and C programming. When was assembly language developed and for what purpose? Stan Poley wrote the symbolic optimal assembly program for the IBM 6500 computer in 1955, or SOAP for short. Began being widely used as they relieved programmers from tedious tasks such as remembering numeric codes. What, if anything, is your language used for? It was used for primitive microcomputers, given the lack of high-level language at the time, large amounts of IBM mainframe software, the Lotus 1, 2, 3, IBM PC DOS operating systems. Most computers of the 80s and 90s, interestingly enough, I can't imagine having to program a whole computer just using assembly language. Kudos to them. The Atari ST and MSX systems. Allegedly, 007 GoldenEye couldn't find any solid evidence to back that claim, but I could find evidence for NBA Jam, which again, that must have been an excruciatingly difficult task, but props. Today's assembly language is based on the original SOAP version. The original SOAP version is this right here on the right. I'm not gonna lie to you, I don't know what it does. I have no idea what is going on. And this here on the left is an example of I guess a template of modern day assembly programming. And the .data is where you initialize all your variables, and the .code is where you use instructions to do what you want your code to do. Key concepts. This is kind of an important slide, guys. Registers are something you don't really deal with in other programs or in other programming languages, but they're very important in assembly. You have your base register, which is, in this example, is EAX is one of your registers, which is 32 bits. That can be broken down into AX, which is the lowest 16 bits in the EAX register. The AX register can be broken down into two smaller registers, I suppose. AH being the highest 8 bits of the lowest 16 bits of the EAX, of the 32 bits in the AX register. And AL would be the 8 lowest bits in the 16 lowest bits of the 32 bits in the EAX register. And for registers, it's EAX, EBX, ECX, EDX, ESI. There's multiple others, but these are the main ones that you use, or that I use, I suppose, in my class. They each have a specified purpose. So, for example, EAX, you generally deal with numbers. EDX, you tend to deal with arrays and strings, and going through arrays and displaying arrays. Your data types, you can deal with integers, with binary numbers, with signed binary numbers, hexadecimal, and signed hexadecimal. You really have to know how to convert between each of these different data types so that you can double check your work. It's a pain. It's painful, but I mean it's possible, I suppose. Instructions, you have a lot. You have the move instruction, the add instruction, the decrease instruction, the non instruction, and sign multiply, divide, sign divide, shift right, and shift left. These all do different things. They're all useful in their own way. And I mean, there's a lot more. These are just the ones that came to mind when I was writing this presentation. Initializing variables and using them. Again, I kind of already went over this. You initialize them in the .data section, and you use them in the .code section. Assembly language is not an object-oriented language. It just doesn't work that way. Assembly language does support if, else, and switch statements. These can be done through a combination of instructions such as the jump instruction, the compare instruction, jump left, or jump less, jump greater. So here we have an example of a if-else program in C. So we're all pretty familiar with this. We've been working with it all semester. And this would be the equivalent in assembly language. I'm not going to really go through explaining it because that would take a long time, but feel free to pause the screen. I did leave tons of comments just to kind of walk you through the process. One quick thing that I do want to point out is, so there's an instruction called, where is it? Dump regs, which you dump your registers onto the screen. This is it right here. So these are all the registers that you're working with. I really only know how to work with these 5. Or no, EDI as well, I suppose. So 6 out of the 10 registers, and your carry flags you also use. So yeah. What loops does assembly language support? It does support loops. So here's an example of a normal loop. What this does is it increments the AX register by 5 times. So you go through the loop, you increase AX by 1, you go through it 5 times. Boom. Here's an example of a nested loop. A few little comments. Nested loops aren't really my forte. They're not too complicated, I guess, but they're kind of hard to explain. Assembly language does not support functions, which doesn't. Does your language support arrays or other collections and lists? It does support arrays. We use those quite a lot, actually. So here, like I said, you initialize your array in the .data. This is an array of 4 elements, and they're each a double word. That means they're 32 bits long. These are hexadecimal numbers, just kind of fun fact, I guess. So here you're putting the address of int array into EDI. Here you're initializing the loop counter, so you're setting it to the length of the array. You're beginning the sum with 0. So here you point to the next, you add an integer, you add EAX and EDI, which is right here. You point to the next element, and then you loop again. So you're just adding all of these into one register, which is EAX. Whoop. So yeah, that was the key differences between assembly language and C programming. I really didn't do it justice. It's a lot of information to cover, but if I have to review these are some of the main takeaways. You deal with registers a lot. Your data conversions are also very important, and your instructions. These are the tools of the trade right here. This is what's going to get you through your programming. What's going to get it going. Yeah, that's pretty much it. Thanks for having me, guys. This was Assembly Language versus C Programming, presented by Jesus Lopez, and have a good one.